Hi, everyone. Thank you so much. It has been a pleasure coming here. This is my first Atlassian Atlas camp, so it's great to meet all the community here. So today I'm going to talk about scaling Forge apps for high data volumes. So if we look at the challenge for enterprise customers, more and more customers are having more Jira issues and Confluence pages. So when we are developing apps, we are dealing a bigger and bigger data sets. So we are going to look at some of the challenges that imposed by that, and we'll do a technical deep dive on what are the constraints, what are the tools that we are working with, and I will propose a solution framework in the end. Let's go through this. The first one, as I mentioned, the data set is getting bigger and bigger. Some of the customers could have easily have millions of Jira issues. We all know how the issues can come in through the JSM, the internal teamwork. We are breaking down the issues. Confluence pages also grow for many customers as the internal knowledge base grows. Not to mention, comments, attachments that is associated with those pages and issues. So the overall data volume is really growing and exploding. There are some use cases tend to deal with the large data set. Not all apps need to do that. But what Opus Guard we deal with is retention management for all those user-generated contents. So we definitely see that challenge in our work. We also see, looking at the whole ecosystem, some other vendors or partners are also dealing with this issue. For example, if you're doing a full backup, you are dealing with the whole scope of the content. Same for the export, if you're doing a large amount of exporting. We also see, maybe importing if you are migrating from other data sources, or maybe migration from, I don't know, DC, I'm imagining there. So if it's not true, tell me that. And I also see, if you want to do analytics on the contents, you're also dealing with a large amount of data. I'd love to hear other use cases. So if you have one, you have been working on some of the problem for the customers, I'd love to hear that as well. Let me know. So today's goal, we really want to try to find our way how we can build an application that can scale with the data volume as the whole business grow and for the enterprise customers. So there are some fundamental, the basics. So let's take a quick look at that to get them out of the way. So the first one that as an app developer, how we access those data is always through the product API, either Jira REST API or Confluence REST API. All of those bulk retrieval endpoints, they all employ some kind of pagination. So you always need to do that. It's a way of the server, the Jira service and the Confluence service breaking down the data for us. It's kind of divide and conquer. It's also, allows them to manage the memory usage. On the server side, it also allows us as a client, as an app, to manage our memory footprint as well. The one important thing that the response of the pagination API request always contains some form of cursor or token that you can use to make the next request to retrieve more data. And those tokens become provides a natural boundary for how we process as well, if you think that way. And it actually provides almost all you need, the metadata you need to do async processing. So this is kind of key enabler for the approach we're going to propose later on. And in case you're not retrieving the data from the product APIs, for example, if you're importing from S3, most of those services also provide you pagination all the way to break down data. So they works in some similar ways, but there's slight differences. But overall, you always want to divide and conquer. if we look at the next one, when we do that, there are a few set of constraints. The first one is the batch size. That basically is the size of the page, the size of results that returned for each page when you do the API call. This is an example of when you call the JQL enhanced search endpoints. This is a relatively new endpoint and deprecates the version 2 search. And if you look at it, if you one thing that affects the batch size is how complex the JQL query is. It's also like how many fields or expansion that you are requesting via the endpoint as well. It affects the number of results that returned or can be returned by the service. In some cases, if you are only requesting the issue ID, for example, you can get up to 5,000 results per request. But as soon as you're adding more fields, you're getting down to maybe 100 or sometimes even less. So that is the batch size is obviously a constraint that you are working with. The next one is the API rate limiting. It's basically how fast you can call those APIs. Combining with the API rate limits and the batch size, that basically determines the upper bound of theoretical throughput you can achieve when you're dealing with the data. So this is something to keep in mind. You can't really be faster than that. This is the upper bound of how fast you can get the data. Some of the key implication of rate limit is that you have to deal with the 429 response with is too many requests. That means that you're being throttled by the service. You're going too fast, and the service wants to protect themselves. So in your app, you have to deal with the 429 response and make sure you do retry and back off. In the resource that provide at the end of the presentation, there's some useful links on how Jira rate limiting works, and there's also some general reference about how to implement the back off mechanism. But again, this also tells us the ability to do async processing is critical, because when you do a back off, when you do a retry, you somewhat need the ability of stop processing and then resume the processing later on. We'll see more details on that a little bit later. The last one about the scaling constraints is something probably most of you are have dealt with, is the Forge execution time limit. For the UI resolver, you have a 25 seconds limitation. For the async functions, you got 55 seconds. And only recent that I think the long-running async functions are going to 900 seconds of 15 minutes. At the time I wrote this slide, it was still in the EAP, and I believe it's now in preview, so which is great. It relaxed a lot of those constraints that we are dealing with as app developers. But keep those limits in mind. We also need to design a mechanism in your function to handle that if you are dealing with a large amount of data. So there's a reference again. It will be in the link provided at the end of the presentation, but there's a really good invocation limits that you want to keep looking at to make sure that you are aware what you're dealing with all the time. Okay, moving on to the solution framework. We already mentioned that the pagination is a key ingredient that we want to bring into our app. It addresses the first constraint, which is the batch size. And the stop and resume capability in your app, based on the async event, could help us address the rate limit and execution time limit. So those are the second and third constraints we talked about. Deep down, going a little bit deep in the async events. So this is a very basic definition of how you define async events in your manifest. You basically have a consumer handler defining an event queue, Q-A in this example, as a key, and then you have a queue name, which is QA, capital A. You have a resolver function defined, then you have a method defined. We'll look at those methods a little bit later in the next slide. Then you define the function. This is consumer handler with a handler name. Then you have the timeout seconds, which is using the long running function as 900 seconds runtime timeout. So this is how you define the async event queue. Smart moving. The remote is not working. Sorry about that. Just give us a little seconds. Okay, here we go. Thanks. The resolver function, this is a long example. I'll break down that for you. So as we mentioned, the function is handling, basically the handler for the async event we defined. It defines the resolver A as a function. And in this loop, it's basically do the pagination call in a loop. And it will try to do a get data, which is a function that wraps around the product API. We don't go into details there, but take that function as the part of the code that will go out to the API and return a data batch, and with the next cruiser for retrieving the next page. And here we have an example, very simple and naive implementation of rate limiting handler. So when we have a rate limit exception, we'll try to determine the backoff delay in some way, and go ahead and try to wait and pass that delay into the queue event. And at the end, we have the while condition there, detecting is there a next cruiser? Is there more data to retrieve? Or do we have execution time exceeded, which basically checks the limits of the runtime duration. So this is basically a very fundamental framework where you repeatedly go call the product API and try to determine is there a rate limit or is there an execution timeout. Before you go out. And if there is a timeout or a rate limit, you try to go there and push out an event, async event. Don't worry too much about the detail. This is just give you a look and feel about how the code actually could look like. Nothing perfect there. But what I want to bring to your attention that, at a higher level, you want to think about what kind of processing model you are actually employ or use, and they kind of affect your architectural decisions and a lot of details how you address your use case. So in this example, this is kind of reflecting to what we had in the code. It's basically a sequential processing method or model. And on the left hand is basically the Forge platform. So when they call the resolver, the first event comes in, it will call the resolver at the top. This is a sequence diagram. The resolve A function will get called. It will go ahead and call the get data to reach the product API, and the product API give you the data and the next cruiser back. And you choose to do to process the data a little bit in those color bars in the resolver. Basically execute whatever you want to do with the data. Then you go on to the next page, you make another call to the API, then get more data and go on and go on. And in the end, you want to determine whether the execution timeout has exceeded or not. If it does, you go back and to the Forge platform and see, this is another new async event with this metadata. Call me back when the time's up. So the Forge will come back. And when the event is triggered, it go ahead and come back with the resolver again. So you can see that in the resolver, it's a single function that dealing with all the data retrieval and data processing. That's why it's called sequential processing. And again, you want to look for the execution time limit and rate limit if you need to do a stop and resume. Just a more complex one that potentially could give you some benefit of, being able to achieve higher throughput, but it also comes with some pros and cons. So this is a model where you have basically it's all the same, other than the processing is being addressed as a separate async event. If you look at the after you retrieve the data back from the API, instead of processing within the retriever A function, you throw back a new async event to the Forge platform, and the Forge platform will start calling a resolver B, which is dedicated to the data processing. And you've seen those color bars running on a separate event handler and separate from the data retrieval threads there. And this is basically a parallel. And because the Forge platform allows you throw out 500, if I remember the number correctly, that would be on the next page, allow you to do 500 events per minute. That means you can spin off many threads to do the data processing. So this allows you to do the parallel processing at a higher throughput. But the risk of doing that is that if you are calling the product API inside those data processing for whatever reason, for example, if you want to create a new issue after you import the data, those are going to affect your rate limit as well. And you need to coordinate your rate limiting response across different functions, right? So that could cause more problem than what you can benefit from. So it's really dependent on your use case and what you actually do with the data processing. So what I'm trying to propose here is that you really need to think very carefully what data processing you're actually doing and identify does those constraints that we talked about earlier also apply to the data processing, and how are you going to deal with it, right? But again, tokens, metadata are passed as a payload for the async data to allow you to do the async processing, as we point out. Also notice that the limits of the payload is different. 200 KB for the async event, but it reduced to 100 KB when you use the long-running function. So the payload limit is different. There's also a hybrid. This is pretty easy to understand. If you can combine the two models, you can process the data. If the data is really depending on the API endpoints and subject to the quota or rate limit, you can choose to do that in the main thread, data retrieval thread, and only spin off the data processing that is not depending on the API, for example. Right? So you can combine those two models. But again, high-level design will give you a advantage about how you're going to design your app. That's pretty much wrapped up. I just wanted to note here, bring to your attention some of the limits. Event per minute is 500. So going back to the model here, that means that how many async events you can throw at the platform per minute from your app. I have never hit that limit, but normally your app will hit the limit before you hit that platform limit in most cases. But it's good to keep that in mind. Payload size, we mentioned that. The other is actually the cyclic invocation limit. That means if you go doing the sequential processing, you keep pushing a new event and Forge keep calling you. You can't go deeper more than 1,000. So keep that in mind. Again, I have never hit that limit myself in our apps, but it's something, if you do have really huge data, you really need to keep that in mind, how you're going to deal with that. But that has been really helpful. That's 15 minutes long running function is really great to help mitigate some of those. Some best practice and takeaways, I'm extending my time, but my suggestion is really start simple. Don't bother with what model or how complexity you want to go there to squeeze out the performance. Start simple first with the sequential processing, then identify what you can spin off and into a separate data processing handler, and make sure you have all the metrics that you monitor the performance, monitor the rate limit. You also monitor your running durations, instrument your code. So you have the data to make better decisions when you want to optimize further. And also keep in mind your use case there before you determine which model you want to use. What I didn't address is really the UI part. We talked a lot about the back end, but the UI part, is going to be a topic for another day. So if you have ideas, questions, problems, challenges you have faced in your UI, I'd love to talk to you and understand that. So I'm still learning as well. I'm backend guy, so I'm also learning the UI part. It's challenging. This is a screenshot of our app. If you look at it, we are dealing with more than 39K in our routine task cases. And how do you present that in your data? If for a better user UI response, it's going to be a challenge. It has always been a challenge there. If you want, can scan the QR code there. It has a link to all the references we have mentioned in these slides. And, I'd be happy to connect with you on LinkedIn and give us a visit at our website as well. Thank you so much.